For questions 15.21 and 15.22, these are very similar to problems we covered in class on Thursday. So 15.21, we're given this 0.05 molar solution of pyruvic acid, which is a weak acid. And we're told that that solution has a pH of 1.87, and we're asked to find the Ka for pyruvic acid. And we're told it's a monoprotic acid. So we know the generic Ka would be, well, what's the concentration of the conjugate base times the concentration of hydronium all over the concentration of my weak acid, HA. So a few things that we know. We know my initial concentration, 0.05 molar, and we know pH. And we know that from pH we can find hydronium, right? Hydronium equals 10 to the negative pH. Hydronium equals 10 to the negative 1.87. Hydronium equals 1.35 e to the negative 2 molar. I got that from the pH. And that also equals my concentration of the conjugate base, 1.35 e to the negative 2 molar. Because in this ionization, in the ionization of a weak acid, I've got HA, my weak acid, it reacts with water to produce hydronium and the conjugate base. And looking at the coefficients from this reaction, for every 1 mole of hydronium that's formed, I'm going to form 1 mole of the conjugate base, right, A minus. So because the concentration of hydronium, I can find that from pH, we automatically know the concentration of the conjugate base because they are formed in a 1-to-1 ratio. Now that I know those concentrations, I can plug in the values, right? So Ka equals 1.35 e to the negative 2 molar conjugate base, 1.35 e to the negative 2 molar of the hydronium, all over my initial concentration of pyruvic acid, 0.05 molar. So square that and then divide by 0.05. I get a Ka of approximately 3.65 e to the negative 3 for pyruvic acid. Be careful, this value, the pH, might be slightly different in your case. The steps would be the same. The trick to 22 is actually harder because they're kind of sneaky here in that they're asking for the Kb of this solution, and they give you the pH. So be careful of that because from pH we find some different concentrations, and Kb is set up a little bit differently than Ka. So for our generic base, I've got a base plus water is in equilibrium with the conjugate acid, BH plus, and hydroxide. So this is where the difference comes in because Kb equals the concentration of my conjugate acid times the concentration of hydroxide all over the concentration of base. The trick though, they gave us pH. So to get started with this calculation, right, sure, I can find hydronium concentration from the pH, but we don't need hydronium concentration, right? We need hydroxide. So the first thing I would do in this calculation is I would convert pH to pOH, right? We know that pH plus pOH equals 14. So that means pOH equals 14 minus 12.2. pOH equals, right, 1.8. And from that, we can now find our hydroxide concentration, right? Hydroxide equals 10 to the negative pOH. Hydroxide concentration equals 10 to the negative 1.8, right? My hydroxide concentration equals 1.58 e to the negative 2. So now I can find the Kb because I know, just like in the previous case, the stoichiometry of my conjugate acid and my conjugate base is 1 to 1. So my concentration of hydroxide equals the concentration of the conjugate acid. So the Kb for ethylamine would be, all right, 1.58 e to the negative 2 times 1.58 e to the negative 2 all over the concentration of my base, 0.5 molar. All right, multiply those two together and divide. I get a Kb of approximately 5.02 e to the negative 4 for ethylamine. And again, as with the previous case, be careful in that this is a variable. That pH is a variable, so your pH could be slightly different. The steps would be the same. The other trick to this question is that because they gave you pH, you would find hydronium concentration. If we use this pH directly in, if we use this pH directly in the form of hydronium equals 10 to the negative pH, we would find hydronium concentration. We don't need that in our Kb expression. We need hydroxide concentration. So that's the trick with this question, is that we've been used to doing this with pH to hydronium. Now we need hydroxide because we're talking about a Kb for ethylamine.